Okay, you guys, I know how much you enjoyed the the system of three equations and how much fun that was solving those by hand. So what we're going to do today is we're going to look at a different way that we can solve this. And I'm going to actually go through with you how to do this using what we call a matrix. You guys have probably heard of that before. And we'll talk about like how to actually do it by hand with the matrix, but actually what I want to show you more is how to do it on the calculator. You know, the things that we did in that last section with solving the systems of three equations, that was kind of enough hand solving, I feel like, solving by hand. So I'm going to show you kind of why this works, and then I'm going to show you to do it on your calculator, and in this section I expect you to use your calculator to solve these systems. So the first thing we want to do is actually define what a matrix is. So, you know, if we have a system of equations, let's say we have 3x minus y equals 1, and let's just do two unknowns for right now, and let's say we have, I don't know, x plus y, let's say equals 7. Okay, so there are a lot of ways that we can solve this. You know, if I wanted to, I could add these two equations together and get rid of the y. But what I really want to point out is when you do that, right, if I did add these guys together, what would I get? I would get 3 plus 1, which is the 4x. Here I would get a negative 1 plus 1, which is 0. And then here I get 1 plus 7, which is 8. If you notice, everything that I'm really doing is only involving the coefficients. So on this first one right here, I mean, technically this is a 4x plus 0y, right, equals 8. And then I can solve for x by dividing everything by 4. I mean, really, you're really dividing the 0y by 4 also, right? And you get 2. So look at what I have. I have 1x equals 2, which from that we can see that x then equals 2, right? So if you notice, all of that work that I did was really just messing around with the coefficients. Remember, there's a 1 in front of here. The coefficients in front of the xy. The x and y's, and then the constants on the right hand side. So what happens then is we're going to use something called a matrix to make this much easier, with the understanding that this matrix, when we look at it, is going to we're going to have those variables represented. We're just actually not going to worry about them. And what this matrix is going to do is it's just going to take the coefficients of each equation. So let's look at this top equation. The coefficient of x is 3. The coefficient of a negative y is negative 1. And then a lot of times we'll put a line here to kind of just delineate like where my equals sign would be. We're not going to put an equals sign, but we're just going to put a line there kind of to describe it. And then what does that all equal? That all equals 1. Then on the, I was going to say denominator. It's not a denominator. The second row of my matrix, what's the coefficient of x here? That's 1. Coefficient of y is 1. And then this is set equal to 7. Okay, so this is what we call a matrix. A matrix is, well, the definition of a matrix is a rectangular array of numbers. So sound it out, Sarah. Rectangular array of numbers. And this we can even break this up like even a little bit more. If I just consider this guy right here, this 3, negative 1, 1, 1, I can actually think of these as two kind of separate matrices. Whoa, that was amazing. I did not mean to do that. Clearly, I meant to erase. Sorry about that. That was pretty cool, though. I'll probably woke you up if you're still awake. I mean, I've only been talking for 4 minutes, so hopefully I haven't put you to sleep yet. If we only looked at the left-hand side kind of my equality here, we call this the coefficients matrix. Coefficient. I guess there's not an S on it, but whatever. This is what we call the coefficient matrix. And then when we actually bring in the solution column right here, this whole matrix right here, then that's what we call an augmented matrix, because it's augmented with the solutions column. Okay, so that's kind of what a matrix is. I think you guys have probably heard of a matrix before. A lot of times we'll talk about a matrix, like if I looked at a matrix, I'm going to call We call them an m by n matrix. So like this matrix right here, I would call a 3, oh, excuse me, not a 3. It's rows and then columns. So this is what we call a 2 by 3 matrix. So the m is the number of rows that the matrix has. And then this n right here is the number of columns. And I'm going to tell you right now, there is a branch of mathematics called linear algebra that you should take someday. Usually you have to have Calc 2 to take that. But it is a wonderful, wonderful, wonderful class that really just delves into matrices. It talks about vectors, vector spaces. It's a really interesting topic in mathematics that takes this idea and then just kind of like expands on it like crazy. So, of course, like I like doing those things. So that's what we mean by a matrix. Again, we usually call it an m by n. And what is the purpose of this again? The purpose of this matrix is to help us solve a system in a way that is a little more easy to deal with than the way that we did in that last section. Okay, so I'm going to just show you a bunch of examples of this. I'm going to tell you what we can do, and then here's what I'm going to do, you guys. I'm going to show you how to do it on your calculator. That's going to be the best thing about the entire thing. So there are a couple things that we can do with a matrix that that doesn't change the system of equations that we have. We talked about this before in 9.2. So the things that we talked about in 9.2, which I'm going to call these now, row equivalent operations. I guess that's just not my word. Or a lot of times you'll hear people talk about them as row operations. And what these row operations are, these are things we can do to the matrix without actually changing the solution of the system. Okay, so it's going to make the system look a little bit different, but it'll be an equivalent system. It'll have the same solutions as the system that we started out with. It's just like when you take an equation and you multiply both sides by a number, it doesn't actually change the answer of the equation, or when you add and subtract to both sides. That's what this row equivalent operation does. So we can do a couple things. We can interchange any two rows, and we haven't changed the system at all. And that kind of makes sense. Interchange any two rows, which, you know, I feel like makes kind of sense. If I add 3x minus y equals 1 and x plus y equals 7, you know, it doesn't matter if I write it as x plus y equals 7 and then 3x minus y equals 1, right? These two systems here are still have the same solution set. Okay, what else can we do to any of these rows? So remember, when I look back at my matrix, what does one of these rows, oh, come on. One of these rows, what does that row correspond to? It corresponds to one of my equations, right? That's what it corresponds to, because it has the same coefficients as that equation. So I can multiply any entry in a row by some non-zero constant. Multiply, oh, not any, each entry in a row by a non-zero constant. And that should feel okay, right? We do that all the time. You've been doing that since you were just a little old Algebra 1 student and you were solving simple equations. So we can multiply, again, if I multiply the whole row, if you look back here, right, if I'm multiplying this whole row by a number, I'm multiplying the right-hand side of the equation and I'm multiplying the left-hand side of the equation. So that's not actually going to change my, again, it's not going to change my solution set at all. I'm going to get the same solutions. And then part 3, which is kind of what we did when we did all of this, but it's definitely what we did when we were solving those system of 3 equations by hand, is remember, and and it's actually what I did back here when I did all that work here, when I added, when I added these two equations together, right, to eliminate one of the variables. That's what this number 3 is going to allow us to do. So we can add a non-zero. We don't want to multiply everything by 0, right? That wouldn't be useful, first of all, and then it would change our solutions. So add a non-zero multiple of one row to another. Okay, So again, I promise I want you to mainly do this with a calculator. So what I'm going to do is I'm going to show you how to do this, and then we're going to use a calculator. But what I want you to, I first want you to understand what we're trying to get to. So let's look at this simple example right here. So my equation is 3, -1, right, augmented with 1, and then I have 1, or my system, 7. So if I were to solve this, right, I would add these two together to get a 0. Now, I'm not necessarily going to do that here. What I want to get to, and I want to kind of show you why this is true. We want to do some stuff here. And when I say stuff, I mean okay stuff. So like row operations. Don't just do whatever you want. And here's what I want to get to. And let me show you why this is what we want to get to here. And then there's going to be some numbers right here. I'm going to just call them A and B. Those are going to be my solutions, okay? Now look at why I want this to be true with the 1, 0, 0, 1. That's what we call the identity matrix in linear algebra and any matrix theory class that you have. But remember what this first column corresponds to. This first column here corresponds to the coefficients for my x's. And this second column right here corresponds to the coefficients for my y's. So notice, if I were to take this matrix and go back into, right, this form right here where I have it as my system of equations, what is this first row going to tell me? I have 1x plus 0y equals, and then I just put an A because I don't know what my solutions are going to be yet. What does this row right here tell me? I have 0x's plus 1y equals b. So look, you guys, if I simplify this, right, what am I going to get? Well, the 0y's go away, and this just tells me x equals a, and here the 0x goes away, and I just get y equals b. Can you tell that I like this stuff? I really love teaching linear algebra. If we had more time, I'd just go and teach you linear algebra right now. So if I can get it into this form right here, and this is what we call reduced row echelon form, or row reduced echelon form. I always forget what it's called. Again, we're not reduced row echelon form. Again, I'm not going to worry too much about you guys doing this by hand because I want you to do this with your calculator. But I'm going to show you kind of how to do it. I'm going to show you one example by hand, and then you're going to do your calculator, okay? And this is called Gaussian elimination to get it into reduced row echelon form. But this is going to be my goal. I'm going to do some stuff to this matrix here to get it over here so I get the reduced row echelon form. A couple of rules about reduced row echelon form. I have to have 1 along the diagonal, and then I need zeros below and above any 1. So if I have like a 3 by 3 coefficient matrix, the reduced row echelon form of this might be something like this. Sometimes we can get some other weird stuff, like I could get a 0 here and still be a reduced row echelon form. But this is what my goal is going to be, is to get 1s along the diagonal if possible, and then getting 0s above and below them. You can get more complicated talking about leading terms and stuff, but we're just not, we don't really have time to do that. So, all right, so let's do an example. Let's do that example really quick that we had. So let's say I have the 3, -1, 1, 1, and then what did I have? 1 and 7. Is that right, you guys? Yeah, that was right, of course. Okay, so what is my goal going to be? So one of my goals is going to be, I want to get, remember what I want to get this to, 1, 0, 0, 1, right? And then some numbers right here, and I'm not sure what those are going to be. So what I want to get, usually the way you want to start, well, I already have a 1 right here, so I could easily get a 1 above this. But what I usually try and do is I try and get this first column nailed down first, okay, the 1 and the 0. So I could easily get a 0. Let me show you how I'm going to do that. And I'm going to show you how I write this. So what I'm going to do is I want to get a 0 underneath that 3. So I'm going to take a -3 times row 2. I'm going to add it to row 1, and then I'm going to put it back into, so what I like to do is put a little colon so I know what I'm going to do here. And then I'm going to put it back into row 2. Okay, so the first column I'm not messing with at all. That's just going to be 3, -1, 1. Okay, then what am I going to do here? I'm going to take a -3 times row 2, and I'm going to add it to row 1, and then the result I'm going to put into row 2. Okay, that's that third row operation that I can do. Add a non-zero multiple of one row to another row. Okay, so let's see what we get here. So if I take -3 plus 3, that's 0. That's why I did it. Here I'm going to get a -3 plus a -1, which is a -4. And then here, what would I get? I get a -21 plus 1, which is a -20. Okay, I hope that makes sense. So now, what else do I need to do? Well, I know I'm going to need to get this one eventually, but what I can do right away is I can see I can get this one pretty easily. So sometimes, you know, there's no unique way for doing this because you guys might do it a little bit of a different way than I do. But I'm going to take a -1/4, leave that top row again as it is. Eventually I'll deal with the top row. I just know I'm going to have to take a third of it, so I'm not messing with it quite yet. So I'm going to take a -1/4 at the bottom row. Remember, I can take any non-zero multiple, and so I get 5 here. Okay, and we're almost there. And then what I'm going to do, again, I'm not dealing with that 3 quite yet because I don't want to deal with the 1/3 yet. But what else, what do I need to get now? I need to get that guy to become a 0. So the great thing is, if I just add row 1 and row 2 and put it back into row 1, I'm going to get a 0. So I'm going to take row 1 plus row 2, and I'm going to put it into row 1. Okay. If I do that, I get 0 plus 3, which again is just 3, but here I get 1 plus -1, which is 0, and then I get 5 plus 1, which is 6. That's pretty great. Then down here I get 0, 1, and 5. Okay, and now look, I have everything I need. I have this guy, I have that guy. Now all I need to find is that, make that a 1. If I make that a 1, I'm good to go. The way I can do that, I can take 1/3 of row 1, put it back into row 1. So notice how I'm kind of describing each step as I do it. As I take 1/3 of 3, that's 1, 0. 1/3 of 6 is 2. Then I have 0, 1, 5 down here. So look at what that's shown me then, you guys. What do I know then? This implies then that 1x plus 0y equals 2, or another way of saying that is x equals 2. Here this says 0x's plus 1y equals 5, or y equals 5. So what's my solution? It's the point 25, where those two lines cross. Okay, I hope that kind of makes sense. I'm going to have you do it all with your calculator, so I don't want to spend too much time on that because I think we spent enough time solving these by hand. But what I do want to show you, no, you know what, I'm just going to show you, let's get crazy. I'm going to show you how to do this on your calculator, but let's get an example going first, one that we can put into our calculator. And we'll do this with, wow, whoops. Sorry. We'll do this with the 3x3. So let's solve using our calculator. Okay. So the system that I want to solve is x minus 2y. Well, solve using matrices and our calculator. Plus 3z equals 9. Then how about a -x plus 3y, and there are no z's, equals -4. And then 2x minus 5y plus 5z equals 17. Okay, so our first step is to get this into a matrix. So I want to get an augmented matrix, and I actually, when I do this, I go column wise. You can go row wise, that is fine. What I like to do is just kind of look at the columns here. What would I have? X is, I go 1, -1, 2. Then for my y's, I would have -2, 3, -5. For my z's, I would have 3. I would have a 0, so let's go ahead and put a 0 there. 5. And then my augmented matrix here, I'm going to augment with the solution column, which is 9, -4, 17. Okay. And then I'm going to put this into this, what we call, it's called reduced row echelon form, or as all the cool kids are calling it, it's called RREF. And the reason that's important is because I'm going to show you how to put this RREF into your calculator. So let's get our calculators. All right, guys, here's my super scientific way of showing you how to do this on the calculator. I did not want to pay to do the emulator on my computer, so I am just literally showing you my video here so ignore this stuff down here and ignore all my post-it notes on my desk. All right, so I have the TI-84. This is going to be true really for any graphing calculator that you have. If you have the Inspire, the Inspire is a little bit different. You'll probably, if you have questions on that, let me know. But like the 84 plus the, what other ones that you have out there, they should be fine. It should be pretty similar. Or Google it. I have total faith in you that you can do that. Okay, so see this matrix key right here? Also, don't mind my fingernails. Didn't kind of realize I was doing this today. All right, so let's get that matrix key. So I'm going to go ahead and go to matrix, and again, I'm going to put in that matrix that we had in just before in my last screen. So I have a couple matrices in here, and this names column is just going to pull up that matrix. I don't want to do that quite yet because I don't have the matrix that I want yet. So if you look in the math is going to be kind of all the operations we can do. And if you scroll up, so press up and keep pressing up, you'll see that RREF. That is what we're going to use. I don't want to use it now quite yet though, because I actually need to put in the matrix I want. So I'm going to edit this matrix. So the first thing this matrix asks for is what is the size of it? So let's look back at the matrix we were using. The number of rows is 3 and the number of columns is 4. So that's what we want to put in there. I already have 3 by 4 in there. So if you don't have 3 yet, put in 3. Okay, then put in 4. Press enter. And then I'm just going to go, it goes row wise as you press enter. So I'm going to go across the row. So I'd have 1, -2, 3, 9. Then when you press enter, it'll go back down to the second row. -1, 3, 0, -4, okay? And then the last one, 2, -5, 5, and 17. Okay, that's how we put it in our matrix. Now I'm going to quit out of there. If I want to pull that matrix up to make sure I put it in correctly, go back to your matrix matrix, table. What am I trying to say? You know what I mean. Go back to our matrix menu. That's what I was looking for. Go to names, press enter. So that's that first column. It'll call up that matrix. And I can check this matrix with what I have. And it looks like I put that in correctly. A lot of times if I don't get the solution I think I should, it's because I just messed up one of those numbers. Okay, you guys, are you ready for this? And you're going to be mad that I didn't show you this before in that last section. So that whole matrix, right, that system of 3 equations that I made you do by hand on the last test and the last homework, watch what we're going to do. Go back to the matrix. If you watched the movie The Matrix, which you're probably too young, but that was kind of funny. I thought that was going to be a totally different movie than what it actually was. Still really good, though. All right, so I'm going to grab RREF. Again, how did I do that? I was in the names. I went over to math. I scrolled up, and I'm going to RREF. This is going to ask me what matrix would I like to take the reduced row echelon form of. I'm going to go back to my matrix menu, and I'm going to call up matrix A. Okay. Close that, and this is so fun. Look at what we get, you guys. Bam, just like that. I get that form that I wanted, right, with the ones along the diagonals, the zeros everywhere else, and that gives me my solution. That tells me x is 1, y is -1, and z is 2, just like that. Not as fun as doing it by hand, I agree, but a little more efficient? Yeah, I think so. So let's write that down. So what I like you to do is just put a little arrow and tell my teacher, hey teacher, I RREF'd it, or we like to say I reefed it. I'm going to get 1 0 0 0 1 0 0 0 1. And then if you notice on your matrix, it doesn't give you this line right here. So you just need to realize that that last column, right, is that this is an augmented matrix. Your calculator doesn't know if it's an augmented or a coefficient, and it doesn't care. The steps it takes are going to be exactly the same because that line doesn't actually influence what happened to the numbers when you do the reduced or when you do the row operations. So, all right, so look at what this is saying. This is saying 1x plus 0y's plus 0z's is 1. So that tells me that x is 1. This tells me 0x's plus 1y, you see it. Y is -1 and z is 2. So if we want to write that as an ordered triple, I get 1, -1, and 2. Easy peasy. Isn't that lovely? Love doing these. Okay, I want to look at one more. Okay, because sometimes, even though we're going to use our calculator, sometimes we're going to get solutions that are going to be a little bit different. So let's look at doing one with our calculator again, but let's look at something like this. X minus 3y plus z equals 1, okay? Then 2x minus y minus 2z equals 2, and x plus 2y minus 3z equals -1. Okay, so what is the matrix for this? Again, I'm going to go column-wise. I would have 1, 2, 1, and I want to see this, -3, -1, 2. Use your calculator, however I want to see you set up the augmented matrix, and then 1, 2, -1. Okay, then I'm going to reef this. RREF. I'm going to show you one more time on the calculator just because I know sometimes it can be a little bit confusing. Put it in your calculator, but then in my final example, I think I'll just assume that you can do it in your calculator yourself. Okay, so let's pick up our calculator. Oh, sorry. I should have got that kind of figured out before. All right, so again, what am I going to go to? I'm going to go to the matrix menu, which is second on this one, x to the -1. I'm going to go over to edit because I want a new matrix now. It's still a 3x4 though, so I'm going to press enter, enter, and then I'm going to go across the rows again. So 1, -3, 1, 1. Then it's going to drop me down. 2, -1, -2, 2. It's going to drop me down 1, 2, -3, -1. Oh, sorry. My super scientific thing here. Now I'm going to call up that matrix again. I'm going to just press second enter until I get what I had before. And I'm just going to make sure that I entered that correctly, which it looks like I did. Can't tell you how many times I've made a mistake just because I entered that incorrectly. Okay, now again, because we've already just done this, hit that recall button. You guys know that, right? Or that entry button there. So if I go second enter, it'll bring back, it'll recall things that I've done before. So I'm going to just recall the RREF of A. I'm going to press enter. Look at what I get. This is interesting. So let's write this down and let's kind of talk about what this might mean. Let me get there. Okay, so what does this mean? Look at what we're going to get. We're going to get 1, 0, 0, right? 0, 1, 0. Then I get a -1.4. I get a -0.8. And you can turn that into fractions too, you guys. If you want, you just hit that math key and make it go to a fraction. Take your answer and put it into a fraction, and it'll actually take your matrix. So if you just hit the math key in the 84 and press enter for fraction, it'll take that matrix and put it in a fraction form for you. But more importantly, look at what this is saying. Let's focus on that last row right there. What is that last row trying to tell me? So remember, look at what this is saying. This is saying 0 x's plus 0 y's plus 0 z's equals 1. So what does 0 of all of these equal? It equals 0. So look at what this is asking you to do. This is crazy. It is asking you to find an x, a y, and a z in the real numbers such that 0 equals 1. I don't think anything's changed over, the last 24 hours since I was asleep last night. 0 cannot equal 1. So what do I know about this system right here? There's no solution. Okay, no solution, because I don't know about you, but I can't find an x, y, and z such that in the real numbers that makes 0 equal 1. If you can, you need to contact me and we'll write a paper or something and get published and become famous, because not going to happen. All right, I want to do one more and then we'll call it good. I want to do one more. There's one other thing that could happen that is kind of exciting, and I just want to talk about it. So let's solve again using a matrix, and here's the system. So x plus y minus 3z equals -1. Then I'm going to have 0 x's, but I'm going to have y minus z equals 0. Then I'm going to have a -x plus 2y equals 1. So here's the matrix that I'm going to get. I'm going to get column-wise 1, 0, -1, then 1, 1, 2, then a -3, -1, 0, then my line for it being augmented, -1, 0, 1, and again I have a 3x4 4 matrix. Okay, so when you RREF this, you get something that looks like this. So I'm going to RREF. I put this into my calculator already. It's the magic of hitting the pause button. And I get 1, 0, -2, -1. Now I'm reading row-wise. I don't know. I go back and forth. And then here I'm going to get 0, 0, 0, 0. Interesting, isn't it? All right, so let's see what's going to happen with this. Again, put that into your calculator. If you have questions on that, of course, ask. But notice I don't have a 1 in this bottom right spot right here, right? So that is why you see that there aren't zeros above that. It's because you wouldn't be able to get rid of these numbers if you don't have a number right here. So let's see what's going to happen here. Is it no solution? Actually, it's not going to be no solution. Let's look at what this first row tells us. This first row tells me that 1x plus 0y's minus 2z equals -1. The second row, what does the second row tell us? The second row tells me that y minus z equals 0, okay? And then this third row tells me just that 0 equals 0, which, you guys, that is a true statement. So this is what we call in linear algebra, we say that there's the presence of a free variable here. So there are an infinite number of solutions to this, and we saw this notation before. My free variable, because it's in the third row right here, my free variable is going to be z. And so what I'm going to do is I'm going to solve these so that everything is in terms of z. So this means that x equals 2z minus 1. This tells me that y is actually equal to z. And then this 0 equals 0, this just tells me that z is equal to z. Z is what we call our free variable. So this says that x is going to be dependent on z. It's going to be 2z minus 1. Y is just going to be z. And then, of course, z is just itself. So what happens here? You pick a value for z, and then your y and your x follows suit. So it's that example that we did before in 9.2, where we have an infinite number of solutions because we have what we call a free variable. Okay? That just means that those planes don't meet in just at one point. Okay. All right, you guys, that was 32 minutes of just beautiful, beautiful work with matrices. I love matrices, linear algebra. You got to take it. So, take that trig, go through Calc 1 and 2, and then do some linear algebra, because it's a pretty amazing way that we can solve linear algebra is a very useful applied part of mathematics that people use a lot to solve really, really big systems of equations, like 2,000 by 2,000 matrices. Pretty amazing. It takes a long time to put them into RREF. So there's some tricks for doing that. I bet you've turned off the video. I know. Anyway, there will be some word problems associated with this one, but again, just like we did in 9.2, put those word problems into a system of equations with 3 variables, and then use your calculator to solve.